Assalamualaikum. Hope you will have subscribed to my channel. So we will proceed to the next topic of digital communication systems, that is why digital. So digital techniques need to distinguish between discrete symbols, allowing regeneration versus amplification. Amplification is in analog and regeneration is for digital that we'll study in next videos. Good processing techniques are available for digital signals such as medium, data compression or source coding, error correction, also called channel coding, A to D conversion, equalization, and security. Regenerative repeaters in digital communications. So, in digital communications, the transmitted signals belong to a finite set of waves. The distorted signals can be recovered to its ideal shape, hence removing all the noise. While in analog communications, the transmitted signals are analog waveform, that is continuous waveform, which can take infinite variety of shapes. Once the analog signal is distorted, the distortion cannot be removed. Performance metrics. In digital communications, metrics are data rate and probability of bit error. Symbols are already known at the receiver. Without noise, distortion, or synchronization problem, we will never make bit errors. While in analog systems, metric is fidelity, that is similarity between original signal and reproduced signals. SNR, signal to noise ratio, typically used as a performance metric. Information representation. Communication system convert the information into electrical, electromagnetic or optical signals appropriate for the transmission medium. So analog system convert analog message into signals that can propagate through the channel, while digital system converts bits that are digit or symbol into signal. Computers naturally generate information as bits or characters. Most information can be converted into bits. Analog signal converted to bits by sampling and quantization, that is A to D conversion. Digital versus analog. So digital systems have some advantages over analog, that are digital signals are much easier to be regenerated. Digital circuits are less subject to distortion and interference. Digital circuits are more reliable and can be produced at a lower cost than analog circuits. It is more flexible to implement digital hardware than analog hardware, and digital signals are beneficial from digital signal processing techniques that we discussed earlier, source coding, channel coding, A to D conversion, etc. And we will discuss in the next videos too. But digital systems do have some disadvantages, that are heavy signal processing, synchronization is crucial, larger transmission bandwidth, and no graceful degradation. Elements of a communication system. Information source, analog or digital, like audio or video signals, are a computer output. Source encoding or data compression, that is converting the source output into a sequence of binary digits, which is called information sequence. Channel encoder. It introduced some redundancy for receiver to overcome the effect of noise and interference. It also adds reliability and fidelity to the received signals. Digital modulator, that we all know. Digital demodulator, actually there are some basics. Communication channel, that is a physical medium used to send signal from transmitter to the receiver, that is cable or wireless, microwave, etc. Channel decoder. It reconstructs the original information sequence from the knowledge of the code used by the channel encoder. Source decoder converts output sequence to original signal. Digital signature nomenclature. So here are some terms that we will be using in digital communication systems. Digital message. Message is constructed from a finite number of symbols, e.g. printed language consists of 26 letters, 10 numbers, space and several punctuation marks. So a text is a digital message constructed from about 50 symbols. M array. A digital message constructed from M symbols. Digital waveform. um, current or voltage waveform that represents a digital symbol. Bit rate, actual rate of information or actual rate at which information is transmitted per second. Baud rate. Baud rate refers to the rate at which the signaling elements are transmitted, number of signaling elements per second, and bit error rate, the probability that